All right, next up is question 2 on the worksheet that says use properties of logarithms to write each expression as a logarithm of a single expression. Okay, so we're essentially doing the reverse of what we did in problem number 1. Okay, so I have an expression like this, log base b of x plus 2 times log base b of y. I want to put all of this together as a single logarithm. Okay, so you want to be thinking about those key properties that we went through in the last video in reverse. So to start here with A, this 2 here is multiplying this logarithm. So from the exponent property, I can bring this 2 then up to the exponent position on the y. So that's going to give us log base b of x plus log base b of y squared. All right, now what do I have? Well, I have a sum of logarithms. So if you have a sum of logarithms, okay, then we can write that as the log of the product through the product to sum property, right? So this will become the log base b of the x times the y squared. And here we've now written this original expression as a single logarithm, and so we're done. Okay. B, we have 3 times the quantity log base b of x minus log base b of y. So here, notice inside parentheses, I have a difference of logarithms. So I can go ahead and combine those as the log base b of the quotient of x over y. And since this 3 is multiplying that difference, this 3 will just be multiplying this logarithm of our quotient, right? So this is just quotient to difference, okay? And so now what can I do? Well, much like we saw here in part A, since this 3 is multiplying this logarithm, it can then come up here in the exponent position, and that's going to give us log base b of x over y to the third power. And now we're done. It's a single logarithm. All right. How about C? We got log of x minus 1 plus log of x plus 1. And I just see that what stands out first, it's a sum of logarithms. So this would be log of this quantity, x minus 1, times this quantity, x plus 1, close parenthesis. Now here, notice this product of x minus 1 times x plus 1, I could go ahead and multiply that out. So this would be x squared, and then plus x, and then minus x, and then minus 1. And that's just x squared minus 1 because these x's in the middle cancel out. So putting that all together, this would say that our original expression is equal to the log of x squared minus 1. And we're done. All right, D, log base 2 of the quantity x squared minus 1 minus log base 2 of the quantity x plus 1. All right, I have a difference of logarithms. So I'm thinking quotient to difference. That's going to then give us log base 2 of x squared minus 1. This will be our numerator for the quotient divided by x plus 1. Okay, now notice this expression inside the logarithm can be simplified because I can factor that numerator x squared minus 1. That's a difference of squares. So it can factor as x minus 1 times x plus 1. And then we're dividing by x plus 1 and see now this factor of x plus 1 will divide out. And so when all is said and done, we're left with log base 2 of x minus 1. And there we have it. All right. Part E, again, it's a difference of logarithms. So let's go ahead and start by using quotient to difference. So this would be log of, so this x squared plus 3x plus 2, that's going to be our numerator. And then we're going to divide that by the x plus 1. Okay, and then much like we saw in part D, I can factor that numerator. Let's go ahead and factor that as x plus 1 times x plus 2. And then we're dividing that by x plus 1. And I can go ahead and divide out this common factor of x plus 1. So when all is said and done, this is equal to the log of x plus 2. All right, pretty nice. Part F, we have 1/3 log x plus 2 log z minus 4 log y. Okay, so a lot of different things going on here. Well, first notice this 1/3 is multiplying this logarithm, so it can come up in this exponent position. So it's going to give us log of x to the 1/3 power. This 2 is multiplying the log of z, so it can come up in the exponent position for z. So this would be plus log of z squared. And then here, this 4 is multiplying the log of y, so that's going to give me a minus log of y to the 4th. Okay. Now, what do I have? Well, I have a sum of logarithms right here. So I can put them together using the product to sum property. So this would be log of x to the 1/3 times z squared. And then I'm subtracting from that the log of y to the 4th. And see, now I have the difference of logarithms, the log of something minus the log of something else. So thinking quotient to difference, I can now combine that as a single logarithm. It's going to be the log of the quotient, where this expression here, x to the 1/3 z squared, is the numerator, and y to the 4th would then be the denominator. And that's going to do it. All right. And then lastly, for part G, we got log base 5 of 1 over x minus log base 5 of 1 over x squared. Okay, so I have a difference of logarithms. So we could go ahead and start by saying this is log base 5 of, and then 1 over x would be the numerator. I'm going to divide that by 1 over x squared for the denominator. Okay, so now let's go ahead and clean up this inside. So over here, just off to the side, let's go ahead and do this. So 1 over x divided by 1 over x squared. Well, that's the same thing as saying 1 over x times the reciprocal of this denominator here, 1 over x squared. So that'd be x squared over 1 for the reciprocal. So now when I multiply, notice I have a factor of x common here. So that divides out, and that leaves me with an x. So this is equal to just x. So the thing I'm taking the logarithm of here, 1 over x all divided by 1 over x squared, it simplifies to just x. So in fact, that expression is equal to log base 5 of x. And that will do it. All right, thanks so much.